For more than 14 years now, without a break of even a single day, there have been people living and working in space to get humankind ready to go out into deep space to find out what's out there. Today, the International Space Station's Expedition 42 crew is doing its part by focusing on science research, developing new technologies, and keeping their spaceship in top operating condition to support all the work.
Anything you have in your home, your air conditioning system, whatever it might be, over time something wears out, a part wears out, and you got to call the guy to come fix it. Well, we don't call anybody, we have to fix it ourselves. That is a major part of living in space, just like living here on Earth.
Station maintenance doesn't just mean fixing things inside. Sometimes it means a trip out the airlock. Wilmore and flight engineer Terry Virts are planning spacewalks focused on new docking adapters for future crew vehicles.
When we have American spacecraft coming to the station again, hopefully in a few years, these spaceships will need to dock, and the docking areas need to be launched and installed.
The only problem is they just don't snap on and work. They have to have power. So the power cables and systems that were designed for the shuttle system are not the same for these docking adapters. So eventually these docking adapters go on, but when they get there, they got to have power. So Terry Virts and I right now are scheduled to run some cables. We're the cable guys.
It's the most cables and the longest cables ever in a 10-year-long assembly sequence with lots of cables. This is the most that's ever been done.
Keeping the station running supports all the science, including experiments on the exterior of the station that point up to gather cosmic particles in the search for dark matter, or look down to observe Earth from a unique vantage point. Inside the station, the human crew members facilitate a wide range of investigations.
We're not scientists necessarily on board, we're like lab technicians. We have to lend our hands to the scientists to physically do a few tasks that of course cannot be done from the ground. It's one of the privileges of being an astronaut is that you really work with, I'd say hundreds, maybe it's more, of people who are really top experts in their fields.
The thing about science is you never know what you're going to get, and the really easy discoveries were all made, 500 years ago. The apple hits the ground, hey, there's gravity. That people, all the low-hanging fruit, so to speak, have already been picked. And so the science that we're doing now is really a link in a chain that might be 1,000 links long.
This crew will work on research ranging from 3D printing to combustion and fire prevention to plant growth and physics and much more. On top of all that, each crew member is a test subject for ongoing research into how human bodies are affected by being in the space environment for a long period of time, as will be the case for the human crew members on future deep space missions. The trick is figuring out how a body that weakens in the absence of gravity can be strong enough to work when it encounters gravity again.
Because getting used to zero gravity was so easy for me, and then you start feeling yourself so comfortable within a couple of weeks. After my 6-month mission, when I came back to Earth, I realized that Earth is not really happy to see me, and my body is not happy to be back to Earth gravity.
So everything about these people is part of the research.
We do experiments to see how blood changes, how skin changes, how bone mass changes, and bone density changes. This is a huge scope of research.
Supporting the work of the crew requires periodic deliveries of new supplies, and this station gets them via cargo ships provided by station partners and private contractors.
All these vehicles are necessary to deliver hardware to the station, water, food supplies, oxygen, everything that supports the operation of the International Space Station.
In February, this crew will oversee the departure of the European Space Agency's final automated transfer vehicle. Its ordinary destructive plunge into the atmosphere will be adjusted to gather data for the future fiery finale of an even larger vehicle, the International Space Station itself.
So to make absolutely and fully sure that we understand this, we are going to guide HTV through a shallow re-entry that should mimic what the re-entry of the space station will be at some point in the future. And we will have I think 100 or more cameras set up to record this.
When Wilmore and his Soyuz crewmates come home in March, Virts becomes commander for Expedition 43. And when he opens the door 2 weeks later for Soyuz commander Gennady Padalka, he'll usher in the International Space Station's first year-long mission, which will be completed by Padalka's crewmates, NASA astronaut Scott Kelly and cosmonaut Mikhail Kornienko of the Russian Federal Space Agency, who will remain on board through Expedition 46. The mission for Virts, Shkaplerov, and Cristoforetti runs into May, adding to the lessons learned in low Earth orbit that will be applied to build humankind's future in space.
If we want to conduct further exploration in a robust manner, those are all lessons that we needed to learn, and I think it will be invaluable for anything we want to do in the future in terms of exploration.